Ever wonder what about 1,000 hours of printing on a single hot end looks like? Well, this is my microswiss hot end. It's the real deal. It's a real genuine microswiss, and it's definitely got over 1,000 hours of use on this particular set of hardware. And on my Ender 3 Pro, which is my workhorse, this thing is printing non-stop, but eventually maintenance needs to be done for one reason or another. I was getting some pretty hardcore clogs, and, well, it's cleaning day. Now, the nozzle is also a microswiss nozzle, and this is their A2 hardened steel 0.4 millimeter nozzle. This one's already been cleaned as best as I can get it. I had let it sit in acetone for 12 hours, and literally the acetone did nothing for me. It did not remove any of the plastic. It, well, just didn't do what I was hoping it would. Now, I have used PLA and PETG in this nozzle, and it does flow relatively nicely. I did get some extrusion problems as of late, which is why I decided to try and clean the nozzle. Eventually, I had to just settle for using my heat gun, and I blasted the crap out of it with heat, and I was just kind of poking it on the inside with some stuff I had to remove the plastic on the inner diameter of the walls. As you can see, it's not perfect. It probably never will be perfect. That's one of the downsides of printing PETG, is that stuff does not dissolve. It doesn't go away, man. You can't get rid of it. Most cleaners won't get rid of it. ABS and PLA, typically acetone will remove it, but remnants of PETG are definitely in here. And it's a love-hate relationship with PETG because I love the material. It's actually relatively easy to print with, in my opinion. But when something goes wrong, it is friggin' catastrophic. But that being said, the main thing I print is Hatchbox True White PLA. I've got something that I've designed and printed, and I make a lot of. And that's why this machine gets used almost non-stop. But moving away from the nozzle, let's take a look at the heat break. Now, the nice thing is I've never actually experienced any filament oozing through the threads up and out of the heat block. There is evidence that it has happened at some points. I suspect that it may have happened during a nozzle swap. I had used a copper, or no, not copper, a nickel-plated brass nozzle from microswiss for a long time, and when that wore out, I switched back to my A2 hardened steel nozzle. Looking at the threads, we're going to zoom the camera in here. Looking at the threads, despite being heavily used, and there's definitely plastic in the threads, that'll be cleaned out. I'm going to use a nylon brush and a little bit of heat with a heat gun, and we're going to melt the plastic out, and we're going to clean it up real nice. That being said, this block definitely held up really well compared to a lot of the Chinesium blocks that I get. You know, the right type of aluminum alloy is extremely important, and microswiss definitely uses the best type of aluminum alloy for this application, mixing a blend of strength and heat conduction. So to get this thing out, you have to back out the screws completely, and then you have to pry it open because it clamps down on the heater cartridge. A design that, I guess, if you want it in there good and not to come out, it's really handy, but removing the block for any sort of maintenance is a bit of a pain in the butt, because you will have to get the block up to temperature and then use something small to pry open this portion, and then you can remove the heater cartridge. So we're going to put that aside. Let's talk about the titanium heat break. Now, during disassembly, I really got a chance to get to know this heat break a bit better. because the reason they use grade 5 titanium is because it has excellent thermal conductivity properties in the sense that it doesn't conduct thermals very well. It's for a metal, it's strong, but also very bad at conducting heat, which is exactly what you want. They call it a heat break because they want to break the chain of heat, more or less. You can just think about it like that as a little tidbit, a little easy way of remembering why these things are called the way they are. Because you don't want heat to travel up the heat break because it's what's separating the heat block from the heat sink, and you really want to just localize the heat on the heat block. So grade 5 titanium is perfect for that. It's strong. Titanium itself can be rather brittle, but this is a good grade of titanium. It's machined well, and it definitely blocks the thermals from traveling up the heatsink. Because I've had this hot end like clipped at 250 Celsius for like 10 minutes straight without a fan on the heatsink, and I could still touch the heatsink and barely feel any heat going up to it. So titanium really does block the heat from moving up extremely well. Chinese heat breaks usually are TC4 titanium, which in theory, or at least spec-wise, is basically the same metal. It's just in China they grade titanium differently than we do in the United States. And despite the fact that this heat break has got a lot of gunk on it, it's performed very admirably. So, cannot fault the heat break whatsoever. And looking at the wear, sorry, my camera is just automatically focusing as best it can. The wear is honestly not nearly as bad as I thought it would be after 1,000 hours. So, this just really needs to be cleaned up. This heat break can definitely be used again. So let's talk about the heat sink. Now, obviously, this is the component where filament gets lodged through, and we want to keep this end as cold as possible so we don't heat up the filament inside of here, because if it gets heated up inside of here and it melts, you will create a horrifying clog. I have done that several times, unfortunately, and it's usually due to a jam. And honestly, most of my jams are not the fault of the hot end. It's a fault of my extruder. I use a all-metal BMG clone, and that thing conducts heat directly out of the stepper motor, and sometimes the plastic gets wound up in the gears of the extruder, and then plastic doesn't move, and when it doesn't move, the heat from the plastic is going to rise up, and eventually it's going to get to the point where if you don't notice it for a few hours, it's going to clog up in the hot end. But normally, my clogs are not a result of the hot end, at least typically. So you can definitely see straight through it. The times where I have had a clog, I've just heated up the hot end with no fan for about 15-20 minutes, as hot as I can, to get the plastic that does get stuck in here, if it's partially melted, to loosen up. And this is probably not the best way of going about it, but I'll take a small Allen wrench and I'll just poke it right through. Just shove it down there with the nozzle out of the heat block, and then whatever plastic was in there, when it softens up, it'll dislodge and come right out. That's the easiest way I found. And, you know, for 1,000 hours, the heatsink, at least in the bottom end, looks really nice. The one problem I will tell you that I have had over and over and over again, and this is the same problem as so many other people, is the Bowden collect staying in place. Now, part of the issue is really not the Bowden collect's fault, it's the Bowden tube. Bowden tubes are slippery, they require some sort of compression and grip to stay in place, and eventually, due to retractions on the machine, it'll pull the Bowden tube back and forth, and that'll create a wearing pattern in the Bowden tube. And that wearing pattern, and I'll show you what it looks like here. that wearing pattern around the end of the Bowden tube where the Bowden collect is gripping, it'll create a gap that gets bigger and bigger, and as it gets bigger, it wiggles more and more and more. I really wish microswiss would release a heatsink that used a pneumatic coupler. I still don't like pneumatic couplers. They're not the best solution, but they are still better, in my opinion, than using a plastic Bowden collect. So let's talk about these Bowden collects. This Bowden collect is definitely not the original. I have gone through probably a dozen or so of these. I actually order these in bulk from AliExpress because anytime you need to do any sort of maintenance that requires removing the Bowden tube, you can pretty much assume the Bowden collect is going to need to be replaced. It will never hold the same way it did when it was new. So in order to get this out, you have to use some sort of tool to pry it out and pull it. So when you do that, you're inherently damaging the plastic that the Bowden collect is made out of. Now this is injection molded plastic, but it's still small plastic. There are better pneumatic couplers out there, like I've got one of these all-metal pneumatic couplers from Triangle Labs, and in theory those are better than your standard pneumatic couplers that are made out of plastic and metal, because there's little teeth that go in there that when you compress, the teeth grab onto the Bowden tube, and that's gonna hold it better than a Bowden collect like this. You can, in theory, tap this heatsink with threads to use a standard size pneumatic coupler. I haven't done that. I'm seriously thinking about it just because of all the times I really wish they would have done it like that, because it's just a better way of doing it. But microswiss, I don't believe, has any plans on changing that. Still, for 1,000 hours of use, it's not bad. And on my workhorse printer, well, the longer I can get